Hey, welcome to another episode of the Empower App Show. I'm your host, Leo Dion, and today I wanted to talk a little bit about patterns and practices, specifically those that are going to help your application over the long term. I know you probably have run into this where as you've built an app or worked on a product or project, bug fixes become more and more difficult to execute and apply to your code base. Also, you probably have found it more and more difficult to add new features to your code base. And part of that is maybe like a lack of organization. Your code's not organized very well, and it becomes difficult to add those new features easily. Also, a lot of times there isn't any organization when it comes to the breaking up of layers or functionality in the application, which makes testing really excruciating and difficult to do. And really, the other thing is without any sort of consistency, new developers have a difficult time trying to apply updates or make changes to the code base that's already there. So that's why today I really want to focus on using the right patterns, modularizing your code, and maintaining good code quality. Because I think by doing those things, you can help your app development process run a lot more smoothly over the long term.
A lot of apps that are built usually start with maybe like one person or a small team. And that person, maybe that developer has an opinion about how to architect the app. And as a team grows and the product org wants more changes, it becomes a lot harder to make those changes if the team isn't on board with one type of architecture.
There's a few architectural patterns I want to talk about. A lot of these are legacy patterns that have come down from Objective-C, but I think you're going to find them super helpful over the long run to know more about, especially as you build an app. One is delegation, which comes from the model view controller pattern. The model view controller pattern is by far Apple's most popular pattern when it comes to developing applications, especially when dealing with how a model or data model is to be applied onto a view. What the controller then does is it understands how to manipulate that view so that it shows the data correctly on the screen. This is, of course, where the delegation pattern becomes more useful. With UI table view controller, for instance, we have a delegate as well as a data source. Both delegate the ability, for instance, to draw cells on each table or each row on each table, how to divide up sections, the number of cells, how those cells look on the screen, and so on. Now, there's benefits to this because then you can break apart a lot of the functionality of your code. But we've seen more shift with Swift to a lot more Swifty patterns and designs. The leading amongst those, I think, is the protocol-oriented programming. The essential idea of this is that everything is designed against a protocol. A protocol essentially sets up the specs of what a struct or class or any sort of type should do in order to be useful in the application. What's really nice about this is that you can then build your application in a way that makes it easily testable, and you can implement a much more test-driven design to your application. Also, we've seen a shift towards functional programming. The idea of this is that you can give methods to different mapping functionality, and that then produces or changes the output of that particular function that's being thrown. So for instance, you might have an array of numbers, you need to filter primes, or you need to double each value. Those are all different ways of doing functional programming. Where we're seeing this a lot is with the new stuff with SwiftUI and Combine, and the idea being of the subscriber publisher model, With this, we have the ability to map publishers and convert values or filter values depending on how useful we see them to be on the UI. The other one, of course, that comes with Swift UI is the shift towards a model view model. With this, rather than having a controller which just draws the values onto the view already has some understanding of what needs to be drawn, and a model view is created which takes the model and converts it into a model that can be used by the view itself. This has become really useful with binding and such. I think we'll continue to see this evolve over the next year or two with the further and further adoption of Swift UI. So we've talked about architecture and how important it is, and the kind of patterns that Apple really likes to promote. We had a great episode a few months ago where Guillermo talked about how important it is to stick with the patterns that Apple really tries to showcase. Because oftentimes sticking with a third-party library isn't going to be a great way over the long term as Apple changes its APIs underneath.
That's a tip I usually give. You can architect an app very well and still use basically model view controllers, but there are ways to architect it still using that, but keeping it sane and not having like the issues that people tend to have with that architecture.
The other thing we want to think about is modularity. What does that mean exactly? This is the idea where individual pieces of functionality are able to work independently, kind of like an interchangeable part. And what this does is it makes it easier to test and easier to reuse these specific pieces of functionality within your set of applications.
However, if you're going to want to really scale this, if you think the project is going to grow and grow and grow, if you think your team's going to grow especially, then definitely I would say that modularization is a really good idea, because as your project grows, there's a lot of things that you can get from having different components in separate modules, right? Even if you're not going to do the whole app, even if you're just going to do some very specific components. For example, your persistence layer is a really good example of something that could be modularized, because you can provide a public API for it, save item, retrieve item, whatever. And the internals can change, and it's not going to matter to the rest of the app that's using it, which means that you can swap out, Realm for core data. You could use Firebase. You could make changes inside, and they're not going to hurt things in the rest of the app because the API is not going to change.
The other thing to think about is this allows for multiple operating systems to use this piece of code. So, for instance, let's say you have a piece of code that you want to use on watchOS, iOS, or server side. You can encapsulate this in a set of libraries or a set of functionality. Chief amongst these, when it comes to components that you could use in Xcode and Swift, is framework targets. Now, we had our episode with Abby where we talked how this stuff works and what you need to know about a framework target. The thing with framework targets is they're a target which an Xcode will build in order to be used in various applications and frameworks. Then these targets can then be applied in different various ways. This is probably the most mature method in Xcode. However, it does come with some legacy baggage that's unnecessary. And there are probably better ways to go about this, especially with Swift packages, which we'll talk about in a little bit. But before that, I want to also talk about projects and workspaces. Because a lot of times there might be a set of code that doesn't really fit with a specific framework. It might be used in separate products and apps. This is maybe where having multiple projects that share code might be a better fit. We talked a little bit in that episode with Abby about how build settings carry through different generations from workspace to project to target. And that's something to keep in mind, where project and workspace might be the right fit. However, it can sometimes be a little bit large and a little bit complex for just sharing functionality. The simplest and probably the future of where things are going is Swift packages. Swift packages are the newest and simplest method for sharing functionality. However, you're limited to Swift only. So in other words, no storyboards or resources or other assets that you might want to use that you probably could do with a framework target. Now, it's not compatible with older apps as well. However, I think Swift packages is fundamentally the future of package delivery in Swift and the Xcode iOS app space. So I would definitely recommend checking that out, especially my article on how to build a Swift package and integrate it into continuous integration packages, such as GitHub Actions and Travis CI. I think in the end, if you can go with a Swift package, that's probably the best way to go. Otherwise, a framework target is totally reasonable. The other way to go is having projects or workspaces if you absolutely have to. Again, check out our episode with Abby Jackson where we talk about frameworks, targets, and modularity overall. So we've talked about how to scaffold your app using architecture. We talked about how to break things into smaller pieces with modularity. But then overall, it's the code quality that I think also matters. By maintaining good code quality, you allow new developers to come in and learn how your application works easily, allows for easy testing, and it also makes sure that it works in an automated setting no matter whose machine it's running on. Chief amongst code quality is testing. Having good test-driven development practices are really important. By doing TDD, that is test-driven development, you're going to ensure that your code works, is modularized, and is not dependent on other pieces of code in order to work. We did a great episode about TDD a few months ago, which I highly recommend you check out.
Two things, especially if you're talking to a CTO, that they like to hear is that maintainability and scalability, and making sure that you have a complete working set of tests allows the team to be more efficient and add features faster in the future. So, you know that you can add something without worrying that you're going to break existing behavior, especially as the app gets more complicated over time.
If you're doing great modularity and you're breaking your application apart correctly, then you pretty much are good to go when it comes to TDD. Besides testing, I think also having good code coverage is a great measurement to know if you're doing the right way. But remember, try not to be too strict when it comes to a lot of these metrics. Especially as developers, we look at metrics and numbers and we want to get to 100%, and that's good and that's great, but sometimes there's more important things to be looking at. One metric that you'll see a lot is complexity. This can be referred to as cyclomatic complexity, and there's also cognitive complexity. Cyclomatic complexity means the number of independent paths within your set of code.
It is basically a measure of the number of paths through a function that your data can take, your code can take. So if you think, for example, of a function that takes one parameter, evaluates one thing about it, whether it's true or false, for example, and then returns that Boolean, you have very low cyclomatic complexity. It's doing one thing. You have one potential route through there, maybe two. If you think of something like a switch statement that has 53 different cases in it, and each of those cases has an if statement nested in there on what it's doing, well, now your code can take a lot of routes through there. And that cyclomatic complexity is just the number of possible paths through the code that that you could take.
So let's say, for instance, you have a function with a lot of if statements or a massive switch case statement. This might be a good case of breaking that functionality into a set of classes or structs, which implement a certain protocol that can check that state, as opposed to having a bunch of branches within your code. This can become really difficult to test over the long run. The other one, which you may have heard of as well, is cognitive complexity. That, while cyclomatic has more to do with testing and the amount of if statements, cognitive is really about having code that's simple enough for anyone to understand. The biggest metric that I think is easiest is looking at how long your files and functions are. They shouldn't be too long. I think a function should be no more than 20, maybe 10 lines. But try to keep it as small as possible. If it's too long, that's another case where a protocol and a struct with its implementation or a class with its implementation should be broken out of that. For instance, with files that are too long, one classic example that I've seen is something like a UI table view controller that implements a lot of protocols. This might be a good case of breaking things into separate extensions that implement those protocols, various protocols in separate files. This is, I think, a really great use case for extensions in Swift, and that's something you should look at as well. Another part of that process is having what's called code reviews. In other words, have an extra set of eyes looking at your code and giving you feedback on what you should do to improve your code. Now, let's say you're working on a solo project. This might be a good example of, say, going for a walk or grabbing a cup of coffee or saving something for the next day or next week to look at. We had a great episode with Anne where we talked about code reviews and how helpful they are. One thing she mentions is having empathy for your fellow developer. I think that's a great way to think about it. By having that empathy, you can make sure anybody can maintain this piece of code, even yourself.
Having empathy for the people who are going to come to your code after you have written it. And those people could include junior developers who don't have the experience that you have. Those people could include people who are new to the project and don't have the context that you have. And those people could include you, future you, who, like I said, pet a dog, had a couple of drinks, went to the zoo and looked at an elephant. And now you're back looking at this code and you are no longer in the context and in the moment you were when you wrote it. You've sort of shed a bunch of short-term knowledge that was really important at the time, but not something you needed to carry on with. And now here you are back in this code. Have you written it in a way that is kind to yourself?
Lastly, and most importantly, is continuous integration. Like I said, we had Kyle on a few episodes ago, and we had that great article we released on continuous integration just recently, where we talked about how important it is for your application.
One of the things I guess I take away from it, sort of from, I guess, a more philosophical perspective, is like there's many things you do to sort of make sure that your app is deployment ready. And some of those things can be automated and some of them can't. The ones that you can automate, you should automate, and you should be doing them every single time, every single day.
There are great services like Circle CI, Travis CI, GitHub Actions, Bitrise, and so on that all help you integrate your iOS application or Swift package or Mac app, whatever it is, into a continuous integration. Like Kyle says, automate as much as you can. This is going to be super helpful in making sure that your application works. By doing that and also doing code reviews, you can help a lot of your system work a lot easier. Another thing to look at is linting, beautification, or formatting. Having consistent styling is going to help your team run a lot more smoothly rather than getting into religious debates about tabs and spaces. By using a tool like, say, SwiftLint, SwiftFormat, Danger, or some of the other various tools out there, you can make sure that your code is consistent so any new team member knows how to format their code and how to style it correctly. In conclusion, I think by following these practices, you're going to help your team a lot. Good architectural patterns mean easy testing. Also, by breaking your application into smaller pieces, it's easier for new team members to understand. It's important to have consistent styling as well when it comes to new developers being brought onto your team. And adding new features don't become so difficult when you have some sort of architectural pattern so that you can see where things that need to be plugged in the right spot. Styling will also help you with version control as well, as you're not diffing based on white space, for instance. And code metrics like code coverage and complexity will help you understand where are places that new developers will have really big challenges. If you can automate a lot of this, that's great, and that's where continuous integration comes in. However, there's always code reviews so that you can have an extra set of eyes and make sure that your code's a little bit more empathetic to your fellow developer, even if that developer is yourself. At first, this might be a difficult thing to implement and may take a little bit of extra time, but in the long run, it will save your team a lot of time and a lot of money, and also will definitely help the morale of your team. I'd love to hear your feedback on this. If you have any comments, please let me know. I'd love to get your reviews on Apple Podcast or Google Podcast, Spotify, whatever app you're using. And also, please share this on Twitter and reach out to me. I'm at Leo G. Dion. You can find my company, brightdigit.com. Again, good to see you, and I look forward to talking to you again. Bye. Testing 1 2 1 2. Starting the recording. All right, let's try this out. I don't hear anything. Do you hear anything? Good. All right.